Alrighty, today what I wanted to do was look at problem number 49 off of the homework. Heard a couple of people had trouble with it and wanted to walk you through it here. Now, this one was a little bit different from a lot of the ones that we have seen. It was talking about the change in internal energy of a gas going from state I to state F. Now what that means is it's starting at some initial state and it's working to some final state. There are two different options in getting there. It can go I to A to F, or I to B, B to F. So basically there are two different paths that it could take. Now, question. When a system is taken from state I to state F along path IAF in figure 1842, Q is 50 and W is 20. Alright, so that means that we're going from point I to point F along point B. So we're talking about this right here. Alright, now, first question. What is work along path IBF? Q is 36. What is W along path IBF? Okay, so what I need to do here is I need to figure out how much energy is at these different locations here. Okay, now, first thing, I know that I'm following path IAF, and I know that through the first law, the change in internal energy of a gas equals the heat added to the gas minus the work done by the gas. So, my change in internal energy in this state is 50 minus 20. So my change in internal energy equals 50 minus 20, which is 30 calories. Okay, now that is not something that's necessary for the first step of the problem, but it is necessary to move on from here. Okay, now here's the thing. With the statement as we've got it here, we know the initial state and we know the final state. So we know the change in energy going from here to here. Well, the nice thing is it doesn't matter what path we take. If we know the change in energy from here to here, it doesn't matter what path we have. We know that this point F, is going to have 30 calories more energy than point I did. So let's look at part A here. On part A, it tells you that if you go along path IBF, the heat is 36 joules. Alright, so, 36 calories, I apologize, 36 calories. Alright, so, I do know from I to F, my change in internal energy is 30 calories. So, change in internal energy equals Q minus W. So, 30 equals 36 minus W. The work done in this case is going to be 6 calories. Okay? So, that's all that we really need to do here, is we need to identify what variable we're looking for and then work right through. It's all with the first law of thermodynamics here. Okay, so if W equals negative 13 calories for the return path Fi. Okay, so from F to I, from here to here, along this path, I'll do it in blue, the work done here is negative 13 calories. Okay. What is Q for this path? Okay, so let me move to another page here. So the work here is negative 13 calories going F to I. Now, I know that the change in internal energy, if I go from I to F, is 30 calories. Now that means if I'm going from F back to I, that means instead of increasing by 30 calories, I'm going to decrease by 30 calories, which means that it is going to drop by 30 calories. So it asks me how much heat, what is Q for this path? So delta E internal equals Q minus W. Negative 30 equals, I don't know Q, minus negative 13. Negative 30 equals Q plus 13. Subtract 13 from both sides. And negative 43 calories in this case. Okay? So, with that in mind, I want you guys to continue to try because I still have not received several of the sheets. I've only received from 3. There are still 5 more out. So, try C, D, and E for 49 if you have not already done so. Okay? Get these to me as quickly as possible. I would like to throw these into the grade book. So, thank you and enjoy.